In this lesson, we're going to be talking about special angle pairs, and we're going to introduce 3 new vocabulary terms. Okay, the first is adjacent angles. Okay, and adjacent angles share a side, and the side is one of the rays that forms the angle. And so this is the side, and they share a vertex. Okay, so by definition, adjacent angles share a side and a vertex. Okay. Because they share a side and a vertex, you'll notice that the angles are right next to each other. Very commonly in schools, classrooms are adjacent to one another. They share a wall. Okay, so it's the same idea. Adjacent angles are right next to each other because they share the same vertex point and they share a side. And you'll notice here, this is an example of a pair of adjacent angles. This is not. These are not adjacent angles, and you'll notice they're not adjacent because they each have their own vertex. So there's an example of each. The next one is a special kind of adjacent angles, because you'll notice here angle 1 and angle 2, they are adjacent, but what's special about them is that they form, they form a line. Okay. So, and these are called a linear pair. Okay. And you'll notice that the first 4 letters of linear pair is line. So this is a pair of angles that form a line. Okay, and what you'll need to remember about a linear pair or a line is that there is always 180 degrees in a line or a linear pair. So what that means is that angle 1 plus angle 2, when I add them together, will always equal 180 degrees. Okay, and you can tell by our non-example does not form a line. It actually forms another angle. So this is not a linear pair. My linear pair is always a straight line. And here's another example of a linear pair. Here we can see that angle ABC is 45 degrees. And if I add that to angle ABD, (135) plus 45 does give me 180 degrees. My last term are what we call vertical angles. Okay, now vertical angles, they share a vertex but no side. Okay, so whereas in our adjacent angles they share a side, that's what makes them adjacent or next to each other. Vertical angles, because they don't share a side, actually sit opposite one another. Okay, so notice here there's our vertex. The pair of vertical angles are 1 and 3. Okay, so you see they share the vertex but no side. So that's 1 and 3. Okay, because angle 1 is formed by these 2 sides that I highlighted in red, and angle 3 is formed by these 2 sides that I have in blue. So angles 1 and angle 2 are vertical, as are angle 2 and angle 4. Those are also vertical. Okay, and what we need to remember that vertical angles are always congruent. Okay, remember, congruent means equal. So anytime you have a relationship diagrammed by either one of these, you'll notice that the arcs, you see how 2 and 4 have a single arc? That tells us that angle 2 is congruent to angle 4. And how angles 1 and 3 have 2 arcs, that tells me that angle 1 is congruent to angle 3. So the number of arcs match that with the angle that has the same number of arcs, and that tells you which angles are congruent. So let's BC. Oops, get a couple of examples here. So here, part A asks us to list 2 pairs of adjacent angles, okay? Now, if you notice, there are 4 angles here, okay? I'm gonna number them as an additional reference. So angle 1, let's first name them, okay? So we get some practice in naming our angles. So angle 1 is ABE, or I can reverse the letters EBA. Okay. Angle 2 is EBC, or I can say CBA. Just remember that the middle letter is always our vertex, okay? And our vertex is our point where our rays come together or meet. Okay, so angle 3 would be angle CBD, and then angle 4 we can name DBA, or I can verse them as ABD. Okay, so 2 pairs of adjacent angles. Okay, now remember, adjacent angles are angles that share a side and a vertex. Okay, so there are actually several combinations here. So we can say angle 1 and angle 2 are adjacent, okay? Because angle 1 and angle 2, they share this side EB, and of course they share the vertex B. But we could also say angle 2 and angle 3. They are adjacent because they share this side BC and our vertex B. We can also say angle 3 and angle 4 are adjacent because they share this side BD. And of course our last one would be angles 1 and angle 4 because they share this side AB. Okay, so all 4 of those combinations, 1 and 2, 2 and 3, 3 and 4, 1 and 4, they're all adjacent angles. Those are just 2. Okay, so the vertical angles. So remember, where the adjacent angles are next to each other, the vertical angles are opposite one another. They don't share a side. So that's going to be angles 1 and angle 3. So 1 and 3, those are vertical, as well as angles 2 and angle 4. Next question, list 4 pairs of linear pairs. Wow, okay, so those are the pair of angles that form a line. All right, so let me do some erasing here because there's a lot of color here, and I want to make sure we clean this up a bit so it's easier to see. Okay, so remember this was 1, 2, 3, and 4. Okay, now the 4 pairs, the 4 angles that form linear pairs, so the 4 pairs of angles that create a line, all right, so are actually the same ones that form the adjacent angles. So you can see it's neat here. 1 and 2 form a line. They form AC. 2 and 3 form the line ED or BD. Actually, ED would be better because B kind of cuts it off. So ED. Then we have 1 and 4. So we had 3 and 4. We've got 1 and 2. We also have 2 and 3. And then we also have 1 and 4. So those are our 4 pairs. Those form our line because we have, so angles 1 and angle 4, as well as angles 2 and angle 3, all form that line ED. Okay, if it was to extend in either direction. And of course, angle 1 and angle 2, along with angles 3 and angles 4, form our line AC. Okay. Oops. Let's see. Oh, where's my eraser? Here we go. Again, I want to erase all the extras, all the extra info. Okay. Find the, so M means measure. So I read this as to find the measure of angle EBC. So let me, first thing I want to do is outline. So EBC. Okay, and so when I outline, that means I'm looking at this angle right here. And we want to know what measure that is. Now, based on our new definition of vertical angles, we know that angle ABC, along with this angle here, DBA, they are vertical. And the other thing I mentioned about vertical angles is that they are always congruent. So angle DBA is congruent to angle EBC. So if DBA is 138 degrees, this will also be 138 degrees. Okay. Now next, it asks us for the measure of angle ABE. So remember, angle ABE is here, okay? And I already know that AC is a line, okay? So if my entire line is 180 degrees, and one of the 2 angles that helps create the line is 138 degrees, then I can do 180, my total, minus one of the angles, and that will tell me the measure of my other angle, ABE. So make this 7, make this 10. So that's going to give me 42 degrees. So that would be the measure of this angle here. Now, I also want to point out that we know ED is also a line and also adds to 180. So we've already done the math, 180 minus 138 to get 42, okay? So that's why vertical angles are always congruent, because they're formed by intersecting lines or intersecting linear pairs.